This is our biostatistics presentation.
For our research question, we are looking at is there any difference in mean glucose level between normal people and obese people? For our dependent variable, which is the response, we have the glucose level. For the independent variable, which is the factor, we have normal weighing people and obese weighing person. For our null hypothesis, there is no difference in glucose level between normal and obese individual. For our alternate hypothesis, the obese people's glucose level is higher than the glucose level of normal people.
As shown in the table, the mean glucose level of the normal and obese are 81.1 and 84.36, which is about the same. Standard deviation measures how spread out the data are. As you can see, the standard deviation of normal and obese are 16 and 15, which is also about the same. Kurtosis is the measure of the peak of the distribution, and it indicates how high the distribution is around the mean. Data sets with low kurtosis tend to have a flat top near the mean rather than a sharp peak. Skewness is a measure of symmetry or the lack of symmetry. As seen from the table, the kurtosis values and skewness values for normal and obese are similar. Hence, from the graph we can tell that both normal and obese are similar and they are normally distributed.
For the type 1 error, null hypothesis is true, but the test statistics tell us to reject. For the consequences, it is very dire is because that the glucose level between obese and normal people is actually the same, but the hypothesis concluded that they are not. This will make the obese subject think that they have a higher chance of getting diabetes and thus going for more health checkup, wasting more money and time.
In type 2 error, the null hypothesis is false, but the hypothesis tells us not to reject it. It means that obese people do have a high glucose level, but the hypothesis test concluded that they are the same. For the consequence, the obese people will seek less medical attentions as they believe that they are normal, and thus there will be dire consequences as they may have a higher chance of getting diabetes due to high glucose level.
We will be using the F-test to test whether the variances are equal. Our test statistics is 1.02, which means the p-value is 0.948, which is greater than our alpha, which is 0.05, and thus accepting our null hypothesis, as this shows that the test is insignificant and we can safely assume that the variances are equal. For the test on the mean, we will be using two independent sample design. Looking at these results, we will have the difference of 3.26 with a lower boundary difference of 8.59, test statistics value of minus 1.01, and a p-value of 0.844. Our p-value of 0.844 is greater than the alpha. Thus, we can accept the null hypothesis as the test is insignificant and hence concluding that the mean glucose level for obese people is actually the same as that of normal people. From our confidence interval, we have the lower boundary which is negative 8.59, which is also shown in this graph. To calculate the power of this test, we need three things, which are the pooled standard deviation, the sample size which is 50 for each group, and the difference which is minus 3.26. Let S1 square be the variance of normal people's glucose level, and let S2 square be the variance of obese people. For the pooled standard deviation, we will be using this formula. Forget it, it's too difficult. We will use this formula instead as the sample size of normal equate to that of the obese. After substituting all these numbers in, we have the answer of 16.0642, which is rounded up to 16.06.
To calculate power, we need to use the pooled standard deviation, which is 16.06, difference of 3.26, and sample size of 50. Keying this into Minitab, we have a power of 26.2%. We increase the power to 90% to detect a notable difference and also keeping standard deviation and difference same. We found out that we need 420 subjects for each group.
Conclusion, as seen in part 1, we can conclude that they are about the same. As from the statistics test, we found out there is no difference in glucose level of normal and obese people, but we do not know for sure whether they are the same. With our current sample size of 50 for each group, the power is relatively weak. In order to get a stronger power, we need to have at least 420